In this example problem, we're going to determine some probabilities by using what they call a two-way table. And a two-way table is basically taking two variables and setting up in a way where one group of variables is the columns and the other group of variables is the rows, or information is read in two different ways, two-way table. And so for us over here, we have a survey which was conducted of 30 adult students at a community college. And one of the questions on there asked whether or not they were a parent. And we got 30 respondents over here in total. How did they respond? Well, we can read this in a ton of different ways. Let's go with parents. There were five parents in total out of the 30 that we had. One of them was male, four of them was female. That means if five were parents, the other 25 were not parents, and 11 male respondents that were in this survey were not a parent. 14 female respondents were not a parent. Or you can go the other way. Out of these 30 people, what portion were identified as men and what portion identified as women? So for men, we had one who was a parent, 11 who weren't parents, 12 males in total replied to the survey. For females, four female students were parents, 14 female students were not parents, but in total, 18 replied. And 12 plus 18 is 30, 5 plus 25 is 30. So you're basically just breaking this down so you can, for lack of a better term, find the intersections. Find how many male students were parents, how many female students were not parents, etc. You're just breaking down the information into the different categories. And for us, we're asked to find some probabilities. The first probability we are asked to identify over here is the probability of male union parent or male or a parent. Well, to figure this situation out, what we can do is figure out how many different people meet this classification. And this is male or parent only has to meet one of the two different criteria. So all of the males would count right here. The one here, I'll just go this way, highlight it. The one male who was a parent, he counts, he meets one of the conditions, meets both of the conditions. So he's got to meet one. The 11 males that aren't parents are still identified as males, so they meet one of the conditions. And also, the four females that are parents, they meet one of the conditions. So the only people in the survey that aren't either male or a parent are the 14 females who are not a parent. So all in all, 16 people in the survey met the condition. So for a union problem, an or problem in here, you only have to be one or the other, but you can be both, and just go through and find all of the points within the data that meet at least one of the conditions. And in us, that is 16. Our sample size was 30. It's always going to be found in the bottom right-hand corner of the two-way table. So 16 out of 30 students, adult students, were either male or a parent, and we could say that 8/15, if we reduce this, of our survey met one of these, at least one of these two conditions. What about the intersection, male and a parent? Well, that means that they have to meet both conditions. And in our survey, there is only one respondent that met both conditions. That's the intersection, why they call it the intersection of these two. We have one male parent out of the 30 people in the survey, or if you will, 1/30th of our sample were parents that identified as male, which you can't reduce because it's already in lowest terms. And this is useful if you are going to project the ratio for something bigger, the population in this case of the community college. If 1/30th of our sample was male parents, we can project that about 1/30th of our entire student body would also be male parents. Down here, we have another intersection, this one female and parent. So we need to go and find how many people in our survey met both and criterias. So female and parent, the intersection between those two variables is right here at 4. So 4 out of the N is still 30, 30 students that took this survey were moms, if you will, female parents. And 4 divided by 30 is 4/30ths, which we can reduce down to 2/15. So 2/15 of our sample, in this case, were female students who have a kid. Let's do the union now of a couple things. We're going to have the probability of M or F. And in this case, that means the probability that a student either identifies as male or female. We don't have any non-binary students in our sample. So I'm thinking in this case, in the absence of any non-binary students, that we are going to should have 100% of our sample meet one of these two conditions. Well, let's go through and figure it out. The probability of M in this case, well, we have a total for male, and it is 12. That meets one of the conditions, and all 18 students who identify as female meet that condition. So all 30 of the N equals 30 students in our sample meet this condition, and 30 divided by 30 is just 1 if we reduce it down to a whole number. And that's the way that it should be. Like they call it exhaustive probability. For all of the different combinations of scenarios that you could have, if you add all of that up, it should come out to 1. It should cover the whole entire 100% of the sample. In this case, it does. Here we've got some fun. We have a straight line right here that determine the probability of P straight line M. Well, what is that straight line? It means given. So when you have a problem that looks like this, the letter after the line is going to be the thing that you care about. You don't care about anything else in the sample except for what is given. So this one is the probability of someone being a parent given that they're male. And it's a fancy probability way of saying what percent of male respondents were parents. So because male is given, I don't care at all about anything in this survey in our two-way table except for this row, this male row. And in this, 1 out of the 12 male students that responded were parents. So that's how I'm going to find my probability here. X would be 1. And in this case, it's just the total of what was given, 12. So the probability that someone is a dad, any one male respondent is a parent, is 1/12, which is already reduced. Let's go through and do another one of these. In this case, we have the probability that somebody is not a parent given they identify as female. So we only care, in this case, about what is given, the responses of students who identified as female, that row. So in this case, we're looking for the probability that somebody is not a parent given that they're female. That means that in this case, 14 out of the 18 female students that responded were not yet a parent. And our X would be 14 people that meet the first condition divided by 18, the total of what was given in the problem, 14 out of our 18 female respondents, not moms yet. So 14/18 of our sample, which we could reduce down to 7/9. And then lastly, as a segue, the fractions is just the way that my brain works. And for a lot of students, I find to be the same. I'll go back to the cards in this case. If somebody is asking you what, your chances of drawing any one given card, well, I would say 1 in 52, and I think most other people would do so. They wouldn't say I have a 1.92% chance of drawing this card. It's just, I mean, it's mathematically what's true, but it's not the way that we process things. We process things basically as the amount of successes we can have over the potential amount of outcomes. So I like fractions when I talk about probability. But for the purpose of doing formulas, they become a nightmare after a while. So you will frequently see probabilities that are expressed as decimals, either to 4 or 5 digits, depending on what type of stuff that you're doing. So let's do another given down here. In this case, the probability of a female student being female, given that they are a parent, but instead of expressing it in fractional form, I'm going to express it as decimal form. So what are we given here? We're given the probability of female given that they are parent. So all I care about is the row or column of what is given. And what is given is that they're a parent, so all I care about are those three numbers right there. Four out of the five students that responded that they had kids identified as female, or four-fifths of them. So four divided by five would be four-fifths, but in decimal form, to four digits, it comes out to 0.8000. So 80% of the parents that responded to our survey were moms. And that's still the same concept going through. We could use this for further calculations going forward. It just makes it easier to do the math when you don't have a whole mountain of fractions within the formulas that you're trying to solve. So in stats, a little bit in this class, much more in higher level statistics courses, probabilities are usually expressed as decimals.